All right. So I wanted to take this time and go over some new technologies I've been looking into. And for today, I'm going to be talking about portable mass spectrometry. So we're taking this technique, this analytical technique that we know and love in the laboratory as mass spectrometry, and taking that out of the lab and trying to see if we can integrate it into a way that's plausible to be applied in field, giving us better real-time analysis of substances and material. So let's talk a little bit about an overview here. So just a little outline. We're going to go over the overview of what this presentation is going to be like. We're going to talk about some of the applications. Where are we finding some of these gaps? Why are this helpful? The uses that we're then going to apply it into, and then the components that we're going to hop around. So that's going to really be the main, bare bones aspect of this characterization of the mass spec here. Talking about the ionization source, what kind of mass analyzers we're using, and then the detectors. Then finally, I'm just going to hit it with the commercial application, just to give us an outlook into what we're looking like and what this technology is really looking like today as a user interface. So the overview. So we're actually at the place now. We're able to take this huge, not huge, but this relatively large and bulky instrument and take it into the field while still maintaining this, our broad stroke key statements of what mass spec is, being highly selective, highly sensitive, and providing a real quantitative analysis, right? So that's one of the main ideas here, because in the past we've definitely had this idea of we can do chemical spot tests in field, which is like a colorimetric analysis, which good qualitative chemistry. However, we're not quite down to the part of quantitative chemistry. With that, it also increases our sensitivity. So then with portable mass spec, we're now getting into a trace evidence analysis instead of a more bulk analysis. Starting to get into this trace analysis aspect. Let's talk about some of these fields. So in the fields, I also included kind of what is the purpose here. Better than benchtop. That's really the mainstay statement here. It's better than our benchtop. I included a picture of a typical benchtop machine, but what was really more stuck out to me was look at this weight and the width here. So we're looking at almost 3 feet across, but we're looking at 220 pounds. Then not including the additional 66-pound pump that goes along with that. So now you're taking a almost 280 300-pound instrument, and we're now able to miniaturize that and take it into roughly 10 to 15 5-pound, somewhere around. I think the commercial use that I'm going to be talking about is going to be, it comes in a roughly 2.2 kilograms. So is that like 5 pounds ish? Somewhere around 5 pounds. So better than benchtop. It's quicker, right? So a lot of the times mass spec would be looked at previously as our last place to go. What is our last place that we're going to get? Last place being mass spec, right? So we have to collect this sample, transport it, make sure it goes through all the right processes, chains of command, and then get it into the laboratory where it's then able to be analyzed quantitatively via mass spec. So with that, there comes a lot of time, right? It takes a lot of time. It slows down our analysis of that substance. It's expensive, right? These mass specs, the benchtop mass specs, can be costing upwards of hundreds of thousands of dollars, if not a million. And ease. We're now getting into a user interface that's applicable and easy to be trained on. It's direct. First responders are able to be using this type of technology and using it effectively. Let's talk about some of the fields that we apply. So this aspect of the presentation let's look at it more of a let's think in the future. Let's try to be almost like dream-esque of it. So let's think about forensics. So imagine you're able to take a forensic analysis, the forensic scientist in the field who is able to now give you quantitative, direct measurement of the substance at the scene during the investigation. We can also talk about public safety. If we're able to use this miniaturization technology, think about real-time analysis of air quality, finding if any airborne chemical warfare weapons, biological nerve agents, explosive residues that are in the air are able to be pumped into this miniaturized mass spectrometer and immediately be notified to the public to increase their safety. We can think about this, excuse me, we can think about this in public safety, right? So at the airport, right? If we're able to detect if there's trace elements of explosives in the air at the airport, as a military appliance application, right? So if we're able to put this on a Humvee or on a soldier in a backpack that's able to monitor the air around them for chemical warfare agents. Then finally, what I also listed here was a surgical application. So they're getting to the point where they're actually able to sense what cells are cancerous and non-cancerous in a biological sample using mass spectrometry, right? So this idea of I'll get into a little bit when we talk about ionization sources, but this idea of laser ablation, right? So they're cutting out the tumor. Let's put ourselves in this. They're cutting out a tumor using a laser to cut around, and with that, immediately goes into a mass spectrometer analyzer, and is able to give direct feedback to that surgeon what cells he's cutting or she's cutting that are cancerous or non-cancerous, and allowing him or her to take out the minimal amount of flesh tissue as possible, right? Really, really cool stuff. Okay, so let's I linked in this quick video here. We're gonna take a look at it and then we'll talk about it. I don't know why it's so very small. Hmm. Apologies, I had to fix that real quick, but let's take a quick look at this video here. University just built a handheld device that can quickly live. Their miniature already been deployed to detect. It's small as a blackberry. And quickly analyzed. Computer displays easily identified prescribed. Awesome. So exactly what we talked about there, right? So that video really outlines the applicability, where we can apply this technology, how it's being used, that gap there talking about how difficult it may be to transport that substance back into a lab using he quoted a $300,000 machine that takes up time and space, and they're wanting to get it down to this idea of being as portable as a phone to detect immediately in their application bacteria or pesticides on food contaminants. So super cool video I wanted to share with you. Let's move on here. So one thing I'm going to immediately pull out. So our main issue that we ran into, right? So one of the main issues that the scientific community ran into when we're talking about the field applicability of mass spec, right, is ionization. Just a factor of mass spec, we need to somehow get these chemicals, these substances into an ionized form for them to then be manipulated. I apologize. For them to then be manipulated by an electric field and be detected using our mass spec, right? So with that, we have to find a way to apply into this ionization source. And this comes to the realm of ambient ionization. So ambient ionization is this idea of ionizing outside of the instrument. You actually saw it here in the video. I don't know if you can see my cursor, but up in the right-hand corner where you see this alligator clip on a triangular piece with this needle coming out, that is a form of paper spray ionization, right? And we'll talk a little bit more about that in the next slide here. So ambient ionization, right? So we talked about a little about paper spray ionization. We also talked about paper cone ionization. And then there's also things as laser ablation, electrospray ionization based ambient ionization. Electrospray ionization based ambient ionization, mouthful, really is just more talking about we have this spray or this plume, so to say, of electron spray, electrons, and we insert our sample into that or introduce it into that plume, and then it gets ionized through that. And you see a figure down here kind of depicting that, right? We have our sample introduction going into our ionization, the ESI plume, and then being sucked into the analyzer and the detector here. Same kind of idea, but you're actually introducing it to the sample surface. This would be a good example of like laser ablation that you're seeing in the lower left hand, where that laser is actually ionizing or really think about it as aerosoling our sample surface for it then to be or ionized by the electro spray here that you see coming across and then inserting into the mass analyzer. So let's get into our applicability here. So we're going to talk about DART very fast, right? So DART is a implication called direct analysis in real time. It was created in the early 2000s, I believe around 2009, 2006, 2009 is when it really started to get going here. It was one of the first ambient ionization sources that were then able to be applied with direct contact of the sample. So the whole change here, right? The shift of mind is when we're falling into this idea of we're no longer need to prepare our sample extensively before we get into our analysis, right? So it was just something that we needed to make sure that we touch upon. It's not as applied into portable mass spec, excuse me, largely because it's necessary to use one of its main agents is using an inert gas accelerated through the particle or through the substance rather into the machine, which really takes that ionization along. So that kind of application of the bombardment of compressed gas has really deduced its applicability to portable. However, paper spray and paper cone spray ionization. This idea, and I include two graphics here, and this is the idea of taking a chemical substance, applying it onto a paper or a porous material, introducing a solvent onto it and applying a very high voltage to then ionize that and vaporize that substance on the paper or on the porous surface to then be processed through the analyzer, right? So this is a really cool thing. So paper spray ionization would be great for trace chemical analysis or liquid analysis versus paper cone spray analysis is really good for bulk solid. excuse me, they both process through the same idea of having a media that is then um, introduced with a solvent and applying a high voltage across it to ionize and vaporize that material. Paper cone, it's just really as simplified as I can get. The major difference here is that the paper is now in a cone to hold that solid material versus just a flat piece of filter paper there. Atmospheric pressure chemical and ionization. So this is a really cool way to actually take chemicals that are in the atmosphere, in the air, and be able to then analyze those specifically. So something called corona discharge. It also uses an inert gas around it, or at least an ionized gas, such as nitrogen or oxygen. So you have this thing called the corona pin. It talks about corona discharge, which is really you're just taking a very high charge on a thin tungsten needle, tungsten filament. It is exciting the molecules around it, and in very simple terms, staying surface level on this idea of water clusters comes from that corona discharge, the corona pin, electrifying the water molecules around it in the ambient atmosphere, and using that as a sort of ionization media for our sample to be ionized through and taken into our instrument here. Some really interesting stuff, great applicability into ambient atmosphere analysis. Let's talk about a mass analyzer. So two main analyzers that we talk about in mass spec in general, right? Benchtop or portable, is a quadrupole and an ion trap. There's also orbit traps. They haven't quite been applied into portable mass spec yet, but they are a very, very great mass analyzer. Let's focus on quadrupole. So quadrupole, you're pretty much having these four metal rods that have opposite charge. So two, so let's say in the horizontal direction will be positively charged, in the vertical direction will be negatively charged, and we're running an AC current, meaning alternating current through those to kind of create a field where ions travel through the center and get either stabilized into the detector or unstabilized outside the detector. For the most part, portable mass spec, we're really applying the use of miniaturized ion traps. As you see here on the right-hand side, apologize for all the coughing, battling a sickness right now. But as you can see here on the right-hand side, you have this ring electrode that's going around the ion source, and we're creating an electric field to almost suspend that ion in the center of the ion trap, and then based off of that frequency, alternating how we're scanning our electric field, then creates a magnetic field, and forcing an ion at a time through the ion trap into the detector. I put in the uses here is that one great advantage of using an ion trap is that we're able to do this idea of tandem mass spec, where we're able to where we can isolate a singular ion in that trap, bombard it again with an inert gas, which is helium, and break that apart via soft ionization or really hard ionization to take that into smaller chunks, and then flush that through our instrument to get a better analysis, better resolution into our detector there. I included linear ion trap geometry just because a rectilinear, I guess, is you can kind of look at it as the combination between a quadrupole and an ion trap. So you're taking this idea of the quadrupole, as you can see, again, if you can see my cursor, but you're looking at this triangle where there's four-sided electrode, 1, 2, 3, 4, and it's kind of suspending our ions in the center and then ejecting them through either the center or the bottom into our detector. Sorry about our detectors. Really, portable mass spec is just in line with the typical. This gold standard here is going to be full multiplier tubes. super basic. They're really, um, funny enough, it's really hard to find good literature about portable mass spec detectors, just because it's such. The problem was never the detector. Photomultiplier tubes are not very big. They're pretty cost effective, um, for what they're using. Long story short, you're having a incoming photon or ion impact a surface and then triggers a cascade effect of electrons to then be put out into a voltage meter, which we can then understand that voltage as a signal in mass spec. Um, Really nothing revolutionary as far as detectors go from portable mass specs. The main issue previously was always isolated towards the ionization source and then being able to effectively miniaturize that ion analyzer. Let's move on to some of our commercial application, right? So MX908 is actually a miniaturized mass spec, which you can see up here in the right-hand corner. I actually pulled a couple images from here from their website. They're a Boston-based company right in downtown Boston. The Quincy Police Department actually actively uses the MX908, which is this miniature mass analyzer that you're seeing up in the right-hand corner here. Actively uses that for crime scene investigation and detection. And it's one of the first widely used commercially available mass spectrometers on the market today. Really great. What you're seeing, they actually, so a very brief overview of exactly what the MX908 uses is it is kind of like a paper ionization source where they actually swab. You're seeing in the bottom right-hand corner here. This bomb tech is swabbing a surface with this swab. It then is inserted to the top. You see that little knob on top of the analyzer of the MX908 inserted into there, where then I'm assuming it is applied a voltage in a solvent, and that is then processed through the actual device and is able to give a user-friendly readout as what that substance is. That is all I have today. There's a brief overview of what is portable mass spec, the miniaturization of mass spec, what components we're using, and the applicability of it in today's realm of forensics and public safety and stuff like that. Thanks so much.